In this video, we will understand about electric charge. So, what are electric charges? So, basically, an electric charge is a property of elementary or fundamental particle such as electron and proton, which give rise to electric force between various objects. Now, what does this mean? What does fundamental particles mean? By fundamental particles, we must understand that those particles that cannot be divided further. For example, electron is a fundamental particle. It cannot be divided further, and the electric charge is responsible for electric forces between various objects. In your childhood, you might have done an experiment in which there is a plastic scale or ruler. You were rubbing it on your hair, then keeping the scale near pieces of paper, and what you were observing? The scale is attracting these pieces of paper. The phenomena was the result of electric charges and electrostatics. So, what is the SI unit of electric charge? The SI unit of electric charge is coulomb, and this electric charge is a scalar quantity, means you can simply add it like scalars. Now, there are two type of charges. One is positive charge and one is negative charge. A proton has a positive charge of plus E and an electron has a negative charge of minus E, where E is the charge of electron and its value is 1.6 multiplied with 10 to the power minus 19 coulomb. So a proton has a charge of E with a positive sign, and an electron has a charge of E with a negative sign. So when you are writing the charge of proton, you will simply put plus sign here, plus 1.6, and if you are writing this charge for an electron, you will simply put minus sign, that is minus 1.6 into 10 to the power minus 19 coulomb. Now, many experiments were made to study the properties of charges. So, let us consider this experiment. So, first, a rigid support. Okay. Now, what I am doing? I am tying a string to this rigid support and attaching a metal bob to this string. Similarly, I am taking another string and attaching a metal bob to this string. Now what I am doing, I am giving a charge of plus q to this metallic bob and a charge of plus q to another metallic bob, means these two charges are of same polarity, means if one is positive then another is also positive. What was observed that when the two charges are same, or we can say when there are two like charges, they will repel each other, means these two bob will move away from the middle line, okay, or move away from each other. Similar thing was also observed when these metal bob were negatively charged. In this case also they move away from each other. Hence, from this experiment we concluded that like charges repel each other. Now consider another situation where one bob is given plus q charge, another bob is given minus q charge. In this case, it was observed that these two bobs started attracting each other, means they just moved towards each other. So, this is also known as the fundamental law of electrostatics. The fundamental law of electrostatics means like charges repel each other and unlike charges attract each other. Consider an example. Okay, when a glass rod is rubbed with silk, the glass rod become positively charged and the silk become negatively charged. So what happened? Let's see. Let's say there is a glass rod and let's say this is silk. When these two are rubbed against each other, it caused heat because of friction, and because of the heat, the electrons of the glass got sufficient energy to jump from glass to this silk. Since the glass is losing a negative charge, so it will become positive, and since the silk is receiving a negative charge, it will become negative. Okay, because electrons are transferring from glass to silk, so silk is getting negative and the glass is becoming positive. During charging, electrons transfer from one body to another. Now, based on electrons, the mobility of electron, or we can say the conductivity, there are two types of material. First material is called conductor, second material is called insulator. Now the question arises, do insulator do not have electron? No, insulator has electron, conductor has also electron, both has electrons. Now what is the difference? That a iron is a conductor whereas wood is an insulator. Diamond is an insulator whereas copper is a conductor. It is only the electrons present inside the samples or the materials. Okay, so a conductor has free electrons, or you can say free charge carriers. So the electrons inside a conductor are free to move inside it, whereas the insulator has bound charge carriers or bound electrons, means they are not free to move inside the material. Okay, so the branch of science that study the electric charges at rest is called as electrostatics, and when we study electric charges in motion, it is called as electrodynamic. Dynamic means motion, static means at rest. Okay, now we will study further about electrostatics, and in this electrostatics we study forces, field and potential due to static charges, that is charges at rest. Now what are the various method of charging a body? So there are basically three methods for charging a body. The first method is friction. You all know what is friction. When two objects are up against each other, heat is produced. Okay, heat is produced, and if this heat is sufficiently high, then the electron will be transferred from one body to another. Okay, this electron will transfer from one body to another. Let's say there are two objects, A object, B object. If these two objects are rubbed against each other, then heat will be generated. Electron of A, suppose electron of A is absorbing that heat and taking it and jumping from A to B. Okay, electron is going from A to B. So A will be positively charged and B will be negatively charged, because B is receiving electron in negative charge. Okay, so it will become negative charge, and A is losing electron, means A is losing negativity, so A is becoming positively charged. Okay, you have seen the example before also, that when a glass rod is rubbed on a silk cloth, the glass rod becomes positively charged and the silk cloth become negatively charged. Okay, there is another method for charging, and this method is called conduction. Okay, conduction. So in this conduction method, when a charged object comes in contact with an uncharged object, there is transfer between the object. Okay, means first of all we will take a charged object, let's say charged rod. We will make it contact, a physical contact with an uncharged object. Now you can see that electrons from these uncharged object will jump to the charged object because it is positively charged in the diagram. Okay, now what will happen, there is transfer of electron from uncharged to charged, so the uncharged become positive now. Okay, and its charge will decrease. The charge will decrease by 1 unit. So here there is 4 plus sign, here there is only 3 plus sign. Okay, so what do you understand? When we make a physical contact of a charged object with an uncharged object, there is transfer of electrons are transferring, means there is charging. So okay, now you can see the uncharged one become charged. This is another method of charging. Now the third method is induction. Okay, induction is a method in which we charge an object without any physical contact. The first two method, that is friction and conduction, these required physical contact between the two objects. But in induction method we do not require any physical contact. Okay, now how we will charge by induction? Let's see. Consider the picture. Okay, now let's say there are two objects, A object and B object, kept on an insulating stand. A and B are initially neutral. Okay, now what I am doing, I am bringing a charged rod in front of this setup. Okay, since the charge rod is positively charged, it will attract the negative charge of this setup. Okay, means A is accumulating negative charge on the left side. Since negative charge will be attracted to positive charge, same time positive charge will be repelled by positive charge, which is accumulated near the surface of B to the extreme right side. Okay, once again, these two are neutral. When you bring a positive rod in front of this positive rod or positively charged object will attract all the negative charges towards left and repel all the positive charges towards right. Now when you will separate these two objects, then negative charges will be remain at left side, positive charge will be remain at right side. Now both objects are charged. Okay, carefully analyze this diagram once again. Here both are neutral, then I brought a positively charged rod. Now what is happening? There is charge separation. A negative charges are accumulated, B positive charge are accumulated. Now I just separate A and B, then A is getting negatively charged, B is getting positively charged, and hence both A and B are charged now. Okay, now we want to check whether an object is charged or not, then there is a device, and that is called as gold leaf electroscope. What is gold leaf electroscope? It is a device used for detecting an electric charge and identify its polarity. Means by using this device you can know whether an object is charged or not, or whether it is positively charged or whether it is negatively charged. Okay, so let's see the diagram. Okay, so what are the components of gold leaf electroscope? First of all, it contains a glass jar. Okay, first of all it contains a glass jar. Then in that glass jar there is a rubber, and inside that rubber there is a hole, and from that hole we are passing a rod. Okay, passing a rod, and which is attached to a metal knob or metal bob, you can say. Now the end of that rod is connected to two gold leaf. By gold leaf we mean very thin foils of gold. Okay, now when you will bring a charged object to the metal knob, the charges are going to transfer from that rod to the rod of the electroscope, then to the gold leaf. Since it is positive charged, so the entire rod will become positively charged. then this will transfer to the gold leaf. Now see, these two gold leaf are positively charged, so like charges will repel, so there will be repulsion. Hence you can check that whether an object is charged or not. If this would be negative, then there will be transfer of negative charges to the rod, then to the gold leaf also. Then this entire setup, like gold leaf of left side, gold leaf of right side, both are negatively charged, they will repel each other. And repulsion is the surest test of charging. You may note that repulsion is the surest test of charging. So what are the steps? A body to be tested each touched with the metal knob. Okay, if two gold leaf repel, if two gold leaf repel, then the body is charged, else it is neutral. It means if these two gold leaf repel, then the object that is contact with the bob is charged. This object is charged. If it is not repelling, means there is no motion here, right? These are just like this freeze, or there is no motion, then this object is not charged. So this is a device, gold leaf electroscope, used to detect whether an object is charged or not. Okay, so this was for today's video. If you liking my channel or finding that this video is helpful, then please subscribe and like it. Thank you.